Good morning, everyone, and welcome to another fascinating session of Social Cybersecurity Working Group. Today, we have Professor Srijan Kumar with us. A fascinating talk is going to be here. But before we get started, I would like to ask everyone here on the audience list to introduce themselves. Just a very brief 30-second introduction. I will start and then I will call out the names as they appear in my list of participants, and then you guys can introduce yourself very briefly. So I am Nitin Agarwal, Malden Energy Chair and Distinguished Professor of Information Science at UA Little Rock. I'm also Director of Cosmos Research Center, that stands for Collaboratorium for Social Media and Online Behavioral Studies. And it is my pleasure to also co-chair the Social Cybersecurity Working Group. And with that, I will ask Billy Span to introduce himself.
Hello, I'm Billy Span. I'm a postdoc research fellow also at Cosmos.
Thank you, Billy. We have next Ahmed.
Good morning, everyone. My name is Ahmed. I'm PhD in mathematics. I'm working with the Cosmos team. Thank you.
Next, we have David.
Good morning. My name is David Stafford, and I'm a PhD student at UALR.
Thank you, David. We have another David Lockett.
Hey, thank you. David Lockett of Meharry Medical College, School of Applied Computational Sciences.
Good. Next, we have Heather.
Yeah, how are you, everyone? My name is Haider Arubai. I'm a PhD student and also working as Cosmos. I'm interested in narrative visualization and extraction and visualization research.
Okay. Marina, you're next.
Hello, everyone. Good morning. I am Marina Gurung, and I'm a master's in information science here at ULR and a fellow cosmographer. Thank you.
Marchan, you're next.
Hello, everyone. My name is Narjan. I'm a first-year PhD student at ULR in information science. I'm also a graduate research assistant at Cosmos. Thank you.
Mary, you're next.
Hi, everyone. Good morning. My name is Mary. I am a graduate student of Business Information Systems and Analytics, and I'm also a graduate research assistant at Cosmos. Thank you.
Wonderful. Next, we have Mohan.
Everyone, good morning. Myself, Mohan, and I'm a master's student of information science, also a graduate research assistant of Cosmos. Good to see you all. Thank you.
Okay. Next, we have Nahian Noor.
Good morning, everyone. This is Nahian bin Noor, master's student and graduate research assistant at Cosmos. Thank you, everyone.
Wonderful. Obianuju Ukeke.
Sorry. Yes, good morning, everyone. My name is Obianuju Okeke, and I'm a graduate research assistant at the Cosmos Lab. Thank you.
To have you. Next, we have Kudirat.
Good morning, everyone. My name is Kudirat Akonji. I am a BISA student, business analytics, and also a graduate assistant at Cosmos.
Good. Next, we have Sayantan.
Hello, everyone. I'm a master's student at ULR, and I'm a graduate research assistant at Cosmos.
Sayantan, you go next.
Yeah, good morning, everyone. My name is Sayantan. I'm a first-year PhD student and also a researcher in Cosmos Research Lab. Thank you.
Wonderful. Now we have Shadi.
Hello, everyone. Good morning. My name is Shadi, and I'm PhD student at UALR and also a graduate research assistant at Cosmos Lab. Thank you.
Wonderful. Surya, you're next.
Hi, good morning. My name is Surya Bhattacharya. I actually do a part-time PhD at ULR and part-time work for this Cosmos Lab. Thank you.
Good. We got a little bit of echo there, but I think we were able to hear from Surya. Next, I have Ugo Chikuwu on my list.
All right, good day, everyone. My name is Ugo. I am a graduate of information science at ULR and a part of the Cosmos research team.
Wonderful. Stephen, you're next.
Hello there. My name is Stephen Dick. I'm a research associate at RMC Research.
Nice. Next, we have Manuddin Sheikh.
Hello there, good morning. My name is Manuddin Sheikh. I'm PhD candidate at ULR and also a GRA at Cosmos. Thank you very much.
Good to have you.
Thanks.
All right. So I think we covered everyone in the list. Perhaps Anulika just joined. Anulika, could you introduce yourself briefly, 30 seconds? Maybe we're having some issues with microphones at Anulika's end. Well, what I'll do is I'll get started, and it is my pleasure to introduce Professor Srijan Kumar, who's an assistant professor at the College of Computing at the Georgia Institute of Technology. He completed his postdoctoral training at Stanford University, received a PhD and master's in computer science from the University of Maryland, College Park, and BTech from the Indian Institute of Technology at Kharagpur. He develops AI, machine learning, and data mining methods to detect and mitigate the pressing threats posed by malicious actors and harmful content to web users and platforms. His methods have been used in production at Flipkart and influenced Twitter's Birdwatch system. He has been selected as an NSF Career Awardee, a Kavli Fellow by the National Academy of Sciences, named as Forbes 30 Under 30 honoree, ACM SIG KDD Doctoral Dissertation Award runner-up 2018, and Best Paper Honorable Mention Award from the ACM Web Conference. He has also won the Adobe Faculty Award and the Facebook Faculty Awards. His research has been covered in popular press, including CNN, the Wall Street Journal, Wired, and New York Magazine. So with that, I turn it over to Professor Kumar for his talk on AI for integrity, equity, and well-being. Over to you.
Thank you so much for inviting me to be here, Dr. Agarwal. And so good to see so many cosmographers. I love the name. Yeah, so I'll talk about how my group has been working on developing various different types of models to improve integrity, equity, and well-being. And this is a topic that we have been working on for quite a long time, primarily because bad actors, fraudsters, misinformation, and polarization threaten the safety, equity, and well-being of users, communities, and platforms online. In my opinion, they pose some of the biggest threats today to public health, democracy, science, and broadly the entire society. And the problem is actually very, very huge. Facebook estimates that 145 million accounts on its platforms are entirely fake, and Amazon estimates 300 million reviews on its platforms to be fake. We of course know how much mis and disinformation around COVID has spread on online social networks and social media in the last 3 years, and the impact that it has had in the in both online but also in the real world, including fueling vaccine hesitancy. Today, propaganda, disinformation, misinformation, and others, they are posing such a big threat that today we are at a crossroads in which if we don't do something right now in terms of detection or mitigation of their harms, both in the real as well as in the online world, that few years down the line, it will go out of hand. And in fact, the cost that information pollution has on the world is huge. Just misinformation of COVID-19 has cost the world around $400 billion. This is stats that have been created, that have been compiled together across various different sources. And this is a huge number, and this is just COVID misinformation from up until last year, I believe, right? So the numbers continue to increase. And you can see all sorts of different areas because of which online mis and disinformation has cost the world. Loss of productivity, tourism, public health burden, stock market losses, and so on and so forth, right? So the cost is huge. And today, it's particularly important to study this because today research has shown that people get more news and information from their friends and family on social media than they get from traditional news organizations. As such, the people who we interact with and the accounts we follow really have the ability to change and shape the way we think about things and the decisions that we make. And it's particularly timely right now because of how prevalent and how powerful generative AI has become, and the democratization of these large language models into the hands of those with ill intention. These are real examples that people have created using ChatGPT to create misinformation. On the left, you see Alex Jones misinformation about the victims of the mass shooting being crisis actors, and ChatGPT was able to generate misinformation around that. Similarly, around Pfizer having certain unpronounceable chemicals in their vaccines, which can be used and weaponized to reduce trust in Pfizer vaccine, for example. So these are two examples, and ChatGPT is just one of the tools that is out there. They can improve their filters so that these particular misinformation instances will not be generated. But we all know that that pretty much with all the different open source models that are out there, anyone can use and generate mass dis and misinformation campaigns on any topic that they want to. And it's not just limited to mis and disinformation. One can create botnets that spread hate speech, create deep fakes, and even phone call scams. This is a real, this happened just a few weeks ago, where a couple in Canada lost around 21,000 Canadian dollars because of some scammer calling them and mimicking the voice or cloning the voice using AI of their grandchild and saying that they're in big trouble and they need money urgently, and because of which the grandparents rushed to the bank and sent money. And I'm increasingly seeing this, like this was a few weeks ago, like very frequently now I'm seeing people posting videos about how their parents or themselves received phone calls from scammers trying to use the voice of their relatives or their family members to get money. I believe, unfortunately, that the problem is going to get even worse, and we really need systems that can help solve this problem. So that's where my students and I have been working on for the last several years, where we are creating AI, machine learning, and data mining methods to from the end-to-end pipeline, starting with creating multi-X detection models, where we look at creation of multimodal, multilingual, multi-platform detection techniques that are accurate in detecting these types of cyber harms. Next, we look at robustness, which means to understand whether and how adversaries are, whether they will be able to break these systems. Because just like we are trying to catch these bad actors and their harms, the bad actors are actively trying to fool these detection systems into believing that their misinformation or their harmful content is actually benign. So we try to be proactive, where we try to understand how robust these systems are so that we can patch any vulnerabilities before these systems go live. We look at the impact and attribute how much harm, what are the real world impact that these cyber harms have. And finally, we create a suite of different mitigation tools and techniques to help solve these problems. And over the years, we have deployed the models that we have created and the tools that we have developed. We have deployed them in collaboration with Flipkart, which uses our fake review detection system in-house. Our work has influenced Twitter's Birdwatch system, which, for those of you who don't know, is a system where it's a platform that Twitter has created, where users can come and flag misinformative content. And our latest tool is being deployed on Wikipedia to empower their moderators and check users. We are also developing different types of tools as part of my NSF Career Award to empower ordinary users to correct misinformation. And through an NSF Convergence Accelerator grant, we are also developing tools for fact checkers. So in today's talk, I'll present some of the work that we have created around detection, some work around robustness, and finally ending with mitigation. And at any point in time, if you have any questions, just feel free to unmute and ask. I love it when it's interactive. Or if you are shy, you can put it on chat, and I'm assuming that that Nitin would be kind enough to convey those questions to me. So let's start with detection. So we all know that misinformation, online hate speech, online harms are there. But they're not just in English, even though we academics like to study English as our as the most studied language. But in fact, 76% of the world does not use English as their first or second language, and around a similar percentage of online data is also not in English, which means that if you look at marginalized communities, think of Hispanic communities or Filipino communities and so on. They don't converse with each other. The members of those communities don't converse with each other in English. They talk to each other in their native language. However, and at the same time, harmful content also spreads in these other languages. But most of the research that has been done is in English. So we here are some examples where you can see that fake political news is spreading in Spanish and so on, right? So we started exploring this idea on how robust, how reliable are non-English detection models, given that most of the research has focused in English. So we developed two research questions to compare English classifiers versus non-English classifiers on equivalent tasks. So let's say you're given misinformation in English and you're given the exact same misinformation in Spanish. Will the misinformation classifiers perform equally well in English versus not in English? And if there is some disparity, then we wanted to bridge that disparity. So that's research question 2. And this is paper that we published last year at ICWSM. So we created multiple tasks and multiple data sets where we took English language content and we translated them to various different non-English languages. So we wanted to generalize. So we created multiple tasks ranging from crisis humanitarian detection, which had over 7,000 Twitter posts on various categories, fake news detection. I'm sure you all are familiar with that task, and emotion detection as well. So we took multiple tasks. All of this content is in English, as you can see. So then we recruited annotators, and we also used automated translations to convert these English language content into exact same non-English language content in Spanish, French, Portuguese, Chinese, and Hindi as 5 representative non-English languages. And we translated the entire all of these data sets, both by humans and machine translations using Marian NMT, which we also validated were high quality. And then we took the state-of-the-art language models in English, in these individual languages, and state-of-the-art multilingual models as well, and benchmarked the performance of these models across these tasks. So these are some examples of the models that we took. What we found was that across the tasks, English model performs much better than non-English language models on the exact equivalent task. So for the same content, the English models get F1 score of 0.71, while there's a 10-point drop as soon as you switch to Spanish. And as you go down this list for Hindi, for example, there's a even higher drop, right? So this shows that there is this disparity. When the same content is in English, the models are able to identify them well or do the classification well. When it's in other languages, it's not able to do so. This, in fact, is consistent across the data sets that we studied and across the languages that we studied. We just last week we got an award from Microsoft to investigate OpenAI's GPT-4 and GPT 3.5 models and explore the multilingual disparity, whether it exists in answering health-related questions, health question answering tasks for English versus in the other languages. So that program is just kicking off, and we'll have results to report in a few months around that. But this is incredibly important task, I believe, like this disparity across multiple languages, because as we increasingly use as non English speaking population increasingly uses these online technologies, because of this disparity, they will be harmed. They will be disproportionately harmed because misinformation in their native language will not be able to be is harder to identify because of the classifiers that are being used. So then we looked at solutions on what potential solutions can be there, and we thought about data augmentation in the way that many of these data points that we looked at also had images associated with it. So we asked, can we use images as additional data, and does that help bridge the disparity? So we created a model that's a late fusion model that uses that uses the BERT models for converting the text, and then a VGG16 very standard model to convert the image into a representation, and then we combined them for the classification task. And what we found was that indeed there is some bridging of disparity. The dark green bars are the performance when you use the image modality. And what you see is that on an average, for English, you see a 5% improvement. And for non-English languages, you see around 11.5% improvement. So there's still disparity, but the difference is reduced. So what this hints at is we are able to bridge, we are able to use additional modalities or additional data points to help solve these problems and to bridge these multilingual disparities. This is, I would say, a very preliminary exploration of using images, but I'm sure that there's a huge room to explore and to write and to research other techniques on how we can bridge, how we can improve the performance of these models by using other modalities of data and also bridge the disparity. So since language gives this disparity issue, we also looked at we have been looking at various different types of non-language based solutions, including graph-based solutions. And graph, I believe, are super powerful. And this is work that we did a few years ago, published at KDD, which uses temporal interaction networks. So temporal interaction networks are these super flexible frameworks that can use to represent various different types of time evolving relationships. So think of users posting or liking or interacting with content, or users interacting with other users, like sending friend requests or following them or retweeting and so on, right? So any sort of interaction that happens in online ecosystem can be represented as a network where two entities interact with one another. For example, you can have users interact with items where any interaction has associated timestamp of when the interaction has happened and an associated feature vector, such as when this user writes, when a user interacts with this item, you can have the feature of what type of interaction it is, which device the interaction originates from, and so on and so forth. And as time goes by, more user nodes and more item nodes are created, and more interaction edges are created as well. So this gives like a super large, super dynamic network, which we can use to mine information and also to understand, also to make various different types of predictions. So we did that by creating a model called Jodi, which learns dynamic representations or dynamic embedding trajectories from the interaction graph. So I'm assuming that everyone knows what embeddings are. But a quick refresher is that embeddings are n-dimensional representations that convert every entity in this graph into a n-dimensional vector in a Euclidean space. That's the most basic version of embedding. But traditionally, even if you're given this dynamic graph, you get a static embedding, which means the embedding of each node is constant. What Jodi wants to do is to convert these embeddings into trajectories so that you can see that how embeddings have evolved over time, so that this user's embedding moved from here to here, this item's embedding moved from here to here to here, and so on and so forth. So these embedding trajectories then become even more meaningful and even more informative than the static embeddings that are there. And we can make very interesting predictions based on these embedding trajectories. So Jodi is the model that is used to convert these temporal interaction networks into these dynamic embedding trajectories. So Jodi stands for Joint Dynamic Interaction Embeddings, and it has two major components: an update component and a project component. Jodi is a mutually recursive recurrent neural network framework where you have in the update component a user RNN and an item RNN. The user RNN takes the user embedding and updates the user embedding whenever an interaction happens. And the item RNN takes the item embeddings and updates it whenever an item has an interaction. And then we have a project component that's able to forecast how embeddings will evolve into the future. So this model is trained jointly for predicting future interactions as well as detecting anomalies. So we evaluated Jodi on this detection task of detecting malicious users on two data sets that we created. And by the way, we have also released that data set if you are interested. So we took the Reddit data set and Wikipedia data set, which has around a few hundred thousands of interactions, and also ground truth of which users are anomalous. So Reddit has 366 out of 10,000 users as anomalous, and Wikipedia has 217 out of 8,200 users as anomalous. And all you're given are the interactions that these users have with these items. In Reddit, these are subreddits, and on Wikipedia, these are Wikipedia pages. So we took various different state-of-the-art graph models that are all listed here on this task of detecting, of identifying, rather predicting malicious users when they will get banned. And what we found is that Jodi outperforms all these baselines by around 12%, very consistently. In fact, these ideas, the idea of generating dynamic evolving trajectories has since then taken off. The Facebook researchers created a very nice model called TIES, which is a more scalable version and a more improved version of the Jodi model that we created. And they use it in production to detect ad payment fraud, fake accounts, and misinformative content. Similarly, on Twitter, they have created a generalized version of Jodi called TGN, called the Temporal Graph Networks, and they use it for various different integrity tasks. My objective of saying this is to say that these graph-based models are incredibly powerful, and they have real-world value and can scale to super large platform scale networks like Facebook and Twitter. And they are able to create these systems that are very meaningful in terms of identifying bad actors and harmful content of various different types. So, and the good thing is they complement very well with other types of textual and multimodal information that you may be familiar with. So that's about detection. I'll pause here and take any questions that you might have around that.
And Professor Kumar, I think we have a question on chat. I can read it up. It says, if we translate non-English data sets into English and then use English models, will this help solve the problems currently we are having? Also, how much translating the language accurate these days, if you have that information?
Sure, thanks for the question. So when you translate English content to non-English content, you use non-English language models because they have more domain information of that particular language. Yeah, so we do that. There are also multilingual models which are aware of multiple different languages, and you can use those as well. The field is evolving so fast that it's hard to keep track of which type of model works better. So we use both of these types of models, and we saw that there is this disparity. Translations are actually quite good. We did we recruited human translators to do the translations, and we also used machine translations. And then we evaluated that machine translation by recruiting another bunch of annotators who evaluated those annotations, those translations, and they deemed it to be equally high quality as human translations. Yeah, so the translations are high quality. Of course, if we would have wanted to augment the data with real misinformation that's spreading in the original misinformation rather that's spreading in the other languages. But it's so difficult to even identify that type of misinformation that we went with the translation route. Yeah. Any other questions?
Yeah, so Kumar, thank you for it was like really clear for the dictionary step. It was very clear. The presentation was really good. I just wanted to ask you about one of the slides. You said that the improvement, do you know like why there wasn't an improvement in the Chinese language? Because I don't see like really that difference.
Improvement in Chinese language. Well, there might be, I mean, it's hard to predict in which language there will be some improvement versus not. I think that's an open area of exploration. It's hard to say why exactly there was this improvement versus why there wasn't improvement in here. Yeah, I think. Yeah, it's hard to predict.
Gotcha. And you chose like 5 top languages, or like why did you choose those 5 exactly?
Yeah, so we chose these languages because of the percentage of the world population that speaks these languages, which is quite high. And these are from different, or at least 2 other non-American continents. So those are the reasons why we chose this. We don't mean to say that the findings will. I mean, we expect, and these are like, we would not call these low resource languages per se. So if you look at like Swahili, for example, that's a low resource language. So we would expect the trend here that you see is very, it has a high correlation between the training data, the pre-training data size that is there. So English language has a very high, very large pre-training data set, while Hindi has the smallest among these. So we see this trend. And since low resource languages have even smaller data sets, we expect the performance to be lower. We did not explore that, but that's part of some future work direction that we are doing right now, maybe for a journal version of this paper.
I gotcha. Thank you so much for explaining this to me, Kumar. Thank you.
Thanks, Heather.
Thank you.
Shantan has a question. I see most of the models says it can analyze in different languages, but when we do analysis in Spanish or Portuguese data, it has been observed that the results, for example, in toxicity, sentiment analysis, are significantly different. So do you think for non-English data, translation is a mandatory step for getting better result? Translate, I don't quite understand the question. But I'll try to answer it based on my understanding. But Shantan, would you actually want to clarify what you mean by this question?
Yeah, so in one of our current project, we were checking some political discourse in the North America. So in that particular project, our data was mostly involved in, Spanish and Portuguese data. So while we were doing some analysis for, sentiment analysis or toxicity analysis, first, the models we were using, it was clearly mentioned that it can be used for the Portuguese and Spanish data. So what we did is that we did the analysis directly with the Portuguese and Spanish data. And afterwards, we did the translation, and then we did the analysis. So what we have seen that for both of the cases, when we are translating it to English data, it is giving us a much more better results. So that's why I was asking, like, do you think like that translating is one of the mandatory steps for getting, better kind of results?
That's a good insight. Yeah, I mean, these models, the translation services have actually quite improved since when I was a graduate student until now. So the translations actually work quite well. So if you see that translating these language, the non-English language data into English, and then doing the same task gives you much better performance, then I mean that's a very important finding for the field. So I would encourage you to explore that and publish that because I don't think that's a very well-known finding, but that certainly is very useful. We did the other way around in this work, right? We took English and we translated into the non-English languages and then used the non-English language models to do the prediction in those. But the other way around could be very interesting as well. Yes.
Thank you, Dr. Kumar.
Awesome. Let me go ahead and I will be happy to take more questions. Feel free to continue putting those questions on chat. I wanted to introduce this area of research that we have been working on robustness, where we are looking at while we are detecting bad actors, how robust these detection models are against these adversarial manipulations that these bad actors do. So remember the Jodi model that I was just talking about, and the ties model that was that Facebook implemented on top of it, right? So we got a Facebook faculty award to look at how vulnerable these models are against manipulation that bad actors are doing, and if there are if there are vulnerabilities, if these models can be fooled, whether we have any way of improving their robustness. So we created this system that can do adversarial robustness benchmarking and evaluation by creating a adversarial text generation system or attack called PETGen. So here's how the system works. So let's say you have the classification model that takes in the user, that tries to do user classification, whether a user is benign or malicious. So this model takes the user and the sequence of posts that the user has written or interacted with on various different topics, let's say, and uses this as input to the classifier, and the model correctly predicts that it's a malicious user, right? So it's a malicious user that's, let's say, giving fake reviews or writing harmful content. And this is any classifier, let's say the ties model that Facebook has. We wanted to explore that if the bad actor writes another post, let's say on another topic, will the model still be able to make a correct prediction, or will the model now take this user profile and classify it as benign? And if it is able to do so, then we can say that the attack is successful. So what we did was we created this PETGen model, which is a text generation model that is able to craft adversarial text based on which the model will be able to fool the detection system. And this paper was published at KDD a couple of years ago. So this is what PETGen looks like. I'm not going into the details, but at the very, very high level, what it does is PETGen is a personalized text generator. So it takes the historical posts that the user has written on these different contexts. It takes a target context. Let's say you, as an attacker, you want to generate post in sports. So it will find which is the most, how relevant historical posts are to the target context, gives that a high contextual post relevance to generate, to pass it through a sequence-based text-aware classifier to generate a preliminary intermediate post. Then it takes in information, then it fine-tunes this generated text based on whether it's able to attack the model successfully, to adapt to the style of the user, and base it and make it more relevant to the recent post that the users have written, and also more relevant to the target context. It optimizes the model balances between the attack performance, which is this objective, with all the other all the other objectives of the model to generate a final attack text. And what we found is that once we use this PETGen model to generate the attack text and use that on Facebook's TIES model, it's able to fool the system, fake user detection system, 1 out of 4 times. This is absurdly high, right? TIES is a model that's in production at Facebook, but it can be fooled by very simple attack, which I just explained, 1 out of 4 times, 25% failure rate. If you talk to any cybersecurity person, they will be astonished because they are used to seeing like failure rates of 0.001, right? So 25% is super high. Facebook, like since this was funded by the by award to them, they know we have shared all these results with them. This is one example of the robustness that of robustness evaluation that we have done. But over the, in the last 1 year or so, we have explored various different robustness systems, robustness of various different systems, including recommender systems. We have a paper at CIKM last year where we look at how robust recommender systems are. We have also explored robustness of large language models, including various different types of few-shot learning models. We just had a couple of papers accepted at ACL earlier on Wednesday to look at robustness of few-shot learning models and robustness of multimodal models. And I think this is a huge and very important area of research, and has become very, very timely as well right now. This AI for safety has become, or rather safety for AI has become important and incredibly timely, with responsible AI taking a front seat in the discussions around generative AI. Because as you can know, as you might have been following, generative AI models are not perfect, right? They don't always work as intended. So there's a lot of investigation, a lot of red teaming work that goes around in investigating how robust, how reliable these models are before they are deployed. But even then, even after deployment, a lot of various different types of vulnerabilities are found. So I believe that the area of safety for AI and responsible AI will become increasingly important. Just another point of evidence around that. Just earlier today, right before I got on this call, I was looking. I saw in the news that in the US, the White House has released a new guidance on generative AI and responsibility around that. So they'll make huge investments around creating NSF AI institutes that can investigate that, and also guidance to red teaming instances for various different generative AI models. So I believe the area around robustness and responsible AI will become increasingly important and ties in very, very integrally with all the work in web safety, equity, and integrity that Nitin and I and many other researchers do. Happy to pause and take any questions before I give some insights on the mitigation side. All right. If not, let me talk about some of the mitigation strategies that we have developed. And one of these was ban evasion. So as many of you who are working in this area of web safety integrity, you might know that it's a whack-a-mole game. You try to identify and ban bad actors on a platform using your classifiers, and then it's so trivial for them to just create new accounts and continue their malicious activities. This is a huge problem. It's called ban evasion, and this always puts us, the defenders, at a disadvantage. We're always one step behind the bad actors who can evade the system so easily. In fact, when we were looking at Wikipedia data, we found that some accounts have created like 20 or more ban evasion accounts after they have been banned. So we created this data set as part of the ACM web conference work last year, 2022, by my students Manoj and Gaurav. And what we did was we took all of Wikipedia data and we identified these ban evasion pairs. So essentially instances where a user was banned and then they created a new account and then were banned again, right? So we look at this data, and then we created classifiers on whether we can identify, whether we can detect these ban evasion accounts and whether we can predict them. And in fact, it's embarrassingly easy to detect them because most of these ban evaders, they write in a very similar way. So when you look at the linguistic patterns, when you look at the interaction patterns of which other accounts they are interacting with or which pages they are editing on Wikipedia, when you look at the temporal patterns, the bad actor in the previous account was always active from noon to 1 p.m. and the new account they created also is always active between noon to 1 p.m. Lunchtime off work they do that, for example, right? So when you look at these patterns, it becomes very easy, and we were able to get a relatively very high performance in terms of this detection. And then we talked to the Wikipedia moderators, and they were like so excited by this because they really are struggling with keeping up with all these bad actors. So right now we are deploying this model to aid these moderators in detecting and attributing these ban evaders. So we have this tool. This is a screenshot of various different parts of the tool that we have developed and are now in the second iteration of discussions with moderators. So the tool has improved quite a lot since the first version that we had envisioned. But on the tool, the moderators can come and give names of 2 accounts that they want to investigate, press submit, and then on the back end, the data is collected for these accounts, and we run our models, and it gives the prediction probability of these 2 accounts being ban evasion pairs of each other. Just giving that is not sufficient because moderators want to understand why the model is making such predictions. So we can visualize the metadata. You can see sentence similarities. It's not a very high quality screenshot, so you can't see the text, but you can see which two, based on what these accounts have written, you can see whether there's any similarity between them. In fact, you see very high similarity between the accounts between the sentences that account 1 has written and account 2 has written. You can see that they have reasonably high vocabulary overlap. So they use similar types of words. They use their LIWC scores are very similar to each other. In fact, their sentiment scores are also quite similar. This was not very surprising to us that we see all these different types of vocabulary similarity, because a lot of research has shown that the linguistic fingerprint that you have is very unique, and it's very hard to manipulate that if you are not actively trying to change it. So based on this tool that we have developed, the moderators, we are hoping will be able to gain a lot of value and save a lot of time for themselves in doing this work. And finally, let me just very briefly talk about something really cool that we are doing. So a couple of years ago, we published a few papers where we found that when misinformation is spreading online, there are a lot of ordinary users on social media who are speaking up against those misinformation, and they're trying to counter that misinformation. In fact, when we looked at around 8 million COVID tweets, among that, of all the countering messages that were there, 96% of those came from non-experts, ordinary users like you and me. We're not professional journalists or fact checkers or government organizations. So ordinary users are very prominent. Ordinary users are very active in countering this misinformation. This work influenced Twitter's Birdwatch, but based on that, what we did was we created, and this was paper that my student just presented this week at the web conference. It was in fact one of the best paper award nominees, where what we do is we create this counter response generation model, where given a misinformation tweet, this is a real reply that an ordinary user makes, "You are born to speak nothing but lies," our misinformation correction, counter misinformation generation model is able to take this misinformation tweet and generate a factual, polite, and evidenced counter misinformation response that directly refutes the misinformation. So if you are interested, so think of it as like fine-tuned fine-tuned version of ChatGPT, but for doing this. And the reason why our model works so well is because we created two novel data sets. One, using crowdsourcing. So we took these misinformation tweets and we asked people to write counter misinformation responses to that. That was data set one. And the second was we took all the counter misinformation responses that people have already made on social media, and then we filtered out the bad ones only to keep the good ones. That was data set two. So we used both of these data sets to train our model, and we have a reinforcement learning based model that's able to generate these counter responses that are reasonably high quality. I can try while I'm answering questions to set up the live demo to see if it actually works. But in the demo, what we did was we fine-tuned the GPT 3.5 model based on the data set that we have to generate these responses. Before I wrap up, I'm happy to take questions, but before I wrap up, all the work that I'm presenting today is thanks to the students, the amazing students in my group, and of course the sponsors. Yeah, happy to take any questions, and I'll stop screen sharing, try to set up the demo, which I should have prior to the meeting, but yeah, happy to take any questions while I'm setting up.
Well, thank you so much, Professor Kumar. This was fascinating. And as you can see from the chat, we've already gotten so many interesting thoughts and questions. I had one quick question, which is probably not as scientific question, but more about absorption of your work. So this is a very important work in establishing guardrails for AI and AI algorithms and application of those algorithms. What are the biggest challenges you have faced in making sure that your work and work from other researchers who are also working along similar lines get absorbed in, say, product development companies or say Twitter, Facebook, and what's your opinion about how to approach such companies or organizations with this type of work?
Yeah, we have adopted a few ways in which we have established these partnerships, conferences and others to meet people there. I mean, these social cybersecurity working group is a great venue to interact with people who are directly working on these topics, but from the industry standpoint. At KDD and WWW, we have this cyber safety workshop that we have been running for some time, and also a MIS2 workshop called Misinformation and Misbehavior Detection Workshop, where we have industry partners come in and these start conversations of potential transitions. We also have collaborated directly with them. So one of the works that was deployed on Flipkart was in direct collaboration with them. So for those of you who don't know, Flipkart is the largest e-commerce platform in India. And that's another way. We also have gotten faculty awards to look into that. So that is a direct point of collaboration. And many times we just open source a lot of our work, and that gets attention and that gets implemented. So, for example, the Birdwatch system that we were able to early influence was not through a direct collaboration, but we wrote the paper and that led to that. Wikipedia is, on the other hand, we have a long-term partnership with them. They're actually quite open to collaborations because it's a very community-driven effort. So yeah, I think a lot of direct collaborations, a lot of open sourcing. Companies love these open source models. But one thing that I've realized over the years is that we as academics tend to develop overly complicated models that may not necessarily be needed in production. So in fact, if you look at a lot of trust and safety systems, they are actually using like very, what we academics would call simplistic types of systems. So having more conversations with industry partners who are able to see what we are to really understand their needs and find this product market fit where our systems can actually actually solve their needs is definitely important.
Thank you for sharing that opinion. And let's see if we have any questions from other participants.
I just wanted to thank Dr. Kumar for that presentation. It was like really interesting, very nice slides, I have to say, with animations. And yeah, I agree that most of the ready products are user, they look into user experience. So yeah, the scientific community is like, you cannot understand the thing immediately. Yeah, I come from that part. I work on user experience. I know what issues are there. But thank you again. It was very clear, and thank you for that presentation.
Thank you. I just posted a video of the demo. I wasn't able to set up the demo in a couple of minutes, but we have released a video. So if anyone is interested in seeing how we can generate counter misinformation responses, please look at the video.
Well, thank you so much for sharing that. And also, we're at the top of the hour, so we can wrap up this session with a brief, quick announcement about our upcoming conferences. So we have SBP-BRIMS conference coming up with a deadline of June 5th. So if you're interested in submitting your work, please feel free to check out the website, which is sbp-brims.org. And the conference also has generous travel scholarships for encouraging minority participants, student early career, interdisciplinary participation, etc. And again, it was our pleasure to have Dr. Srijan Kumar talk to us today. And thank you all for joining in. And with that, we will see you again in a month. Thank you all for joining.
Thank you for inviting me, and thanks for the questions.
Thank you.
Thank you.